everyone, welcome back to Distributed Generation and Smart Grid lecture series. Here we are going to discuss about the smart sensors. A smart sensor is a device that takes input from physical environment and which actually uses built-in computer resources to perform predefined functions upon detection of specific input and then process the data before passing it on. So a sensor is capable of manipulation and computation of the sensor derived data. The sensor plus interfacing circuit is known as is a combination of a smart sensor and which is capable of two-way communication, and it can make decision also. So a sensor basically will consist of a sensing unit plus a actuator, which is a unit used for taking corresponding actions. So sensors are very important component in a smart grid architecture, because we need to sense the different variables and to communicate with the central system and also with the consumers. So there are many type of smart sensor which is having the qualities such as enhanced sensing capacity, efficient communication, diagnostic properties. It can handle various smart tasks. So a smart sensor is a sensor actually producing an electrical output when combined with the interfacing electronic circuit is known as a smart sensor. It is a combination of both sensor and actuator. It is simply physical, biological or chemical input and convert it to the measured value into a digital format. So there are different types of sensors. The sensors which are measure current over the time in a particular asset, then water presence which detects the moisture content in a particular unit, then ultrasonic sensors, vibration sensors, temperature sensors, etc. So this is a pictorial representation of various kinds of sensors. Position sensor or presence or proximity sensors, motion sensors, velocity, displacement sensors, temperature sensors, humidity. So there are various types of smart sensors are available. So a smart sensor is composed of many processing components integrated with the sensor on the same chip. The objectives of smart sensors are to integrating and sustaining the distributed sensor system, measuring intelligently or smartly, or to crafting a general platform for controlling and computing. And a smart sensor is to yielding cost effectiveness and communication towards a common goal. Then interfacing different types of sensors. Smart sensor enables accurate and automated collection of data with less noise, and it is used in monitoring and control mechanisms of smart grid. Then this is a functional block diagram of a smart sensor. You can see various components in the smart sensor: sensing unit, signal conditioning, then analog to digital conversion, application algorithm, Then it is associated with a local user interface, memory, and a communication unit or trans receiver. So here the sensing unit senses the changes in the parameter, and then it is conditioned and converted to digital signal using signal conditioning and digitalization units. So we are using a analog to digital conversion or ADC, which is included in signal conditioning and digitalization unit. It convert sensed analog signal to digital. Then these signals is processed and analyzed by an application algorithm. Data transferred to the local users through local user interface. Communication unit used for transmitting and receiving sensed signals and commands. So this is a basic block schematics of a smart sensor. So a sensor systems arranged in three tiers: local level and station or feeder level and centralized control room level in a smart grid structure. So the disadvantages of a smart sensor is the smart sensor consists of both actuators and sensors. So it is more complex than other simple sensors. The complexity is much higher in the wired smart sensors. As a consequence, the costs are also higher in a smart sensor. And let's move on to automatic remote meter reading or automatic meter reading, or sometimes it is comes under automatic meter infrastructure AMI. And the automatic meter reading is automating the process of measurement through digital communication techniques. So in earlier system, electromechanical type meters are used. They have low accuracy, and there is no control over it. There is no communication, or two-way communication is not possible, and theft detection also poor. Then current we are using digital solid state meters. They have high accuracy, but control is limited. Communication is also limited. Then theft detection is possible at nodes only. Then next generation metering system are the smart meter. They have very high accuracy, full control. Then communication is built in, two-way communication is possible. Then theft detection is high. So this is a simple comparison of the various metering systems we used in past, current, and next generation. The critical benefits of automatic meter readings can be listed as ability to detect the tamper events and outage occurrences. Then we can remotely connect or disconnect power supply through meter by using this kind of smart metering systems. Then calculate transformer loading from interval data, and this will take at least minimum 15-minute interval data, which gives the accurate load information for supply scheduling, switching operations, planning, etc. So we are continuously monitoring the various parameters so that this data is will be available in our database, so that we can forecast or schedule or we can plan the switching operation, etc. So monitor voltage at each premise to know condition when to operate capacitor switches or regulators. Then consistent and granular data for improved accuracy. You will get a granular data or complete data sets which will be available in our database that can be used for various analysis purposes. And other benefits are lower cost to read the meters, more accurate and complete reading. You will get automatic meter reading, working as a two-way communication with each other, theft of service detection and prevention, downloading of all relevant data from the meter installed at consumer premises. That is, all the details which are we can collect it as a granular data that will be saved in your meter, so you can download it for further analysis. Or then precise consumption information, clear and accurate billing is possible, automatic outage information and faster recovery, better and faster customer service, flag potential high consumption before customer gets a high bill. That means the customer is well aware about their energy consumption, because we are measuring the continuously the energy consumption, and in each interval the meter will communicate with the consumer regarding their energy consumption, so that they can manage their energy consumption very well. So these are the some of the benefits of AMR. And what are the primary components in an automatic reading system? So primary components are meter interface module and communication system, then central office equipment. So meter interface module, communication systems and central office equipments are the primary components in the system. And in a broad way, automatic meter infrastructure will consist of smart meter, communication infrastructure, head end system, meter data management system, MDMS, then a web application with the updated online data of consumers, then mobile app, etc. will consist of. Then what is this particular meter interface module? That means meter interface module. Smart metering consists of a meter interface module with the power supply, battery backup and required controlling module, and a communication interface that allows data to be transmitted from these remote devices to a central location. So in many instances, this communication interface is bidirectional and allows the central office signals to be received by the remote unit as well. So that is a meter interface module. And some means of translating reading from rotating meter dials or cyclometer style meter dials into digital form is necessary in order to send digital metering data from customer side to central point. So this is what inside the meter interface module. So this may be electro-optical interface, and this utilizes the signal processing applications in electronics, and it requires a RAM and program memory. Then communication systems is another part of automatic meter reading system. So this used for transmission of data and control send signal between the meter interface unit and the central office. So typically such communication takes the form of telephone, radio frequency, GSM, and over sometimes through cables also. So this is used for transmission of telemetry of data and controls send signal between the meter interface unit and the central office. So either GSM based communication or PLCC based communications. GSM based single stage communication between meter and central station through GSM modem is possible. Then PLCC means power line carrier communication is also used. So power line carrier communication is the most economically viable technology for transferring meter data to a data concentrator unit or DCU. It uses the technique of communicating data over existing electrical lines which carry low tension power to the site. It employs an application specific IC which accepts the digital data and convert it into a frequency shift keying modulation and transmit it over to the power line by sensing a zero crossing of 220 volt sine wave. So typical frequency used for frequency modulation is 132 kilohertz. And another component in a AMR is a data concentrator unit. So the data concentrator site on the loop of secondary of the distribution transformer collects meter readings from all the meters using a power line communication system at a predefined intervals. So the DCU and all the meters connected to it can be considered as a subsystem of this automatic meter interface. Then central office systems. Central office systems includes modems, central server, and client software for data acquisition and data analysis.